Hello. Now we're going to look at multiplying expressions with a focus on indices. So indices is our name for the powers on our number or the exponent of the number, the little numbers that we have in the right-hand corner of our bigger numbers or our letters. So let's start with a quick refresher. What does 4 with an indice of 2 mean? Well, that means 4 to the power of 2. We'd often call that 4 squared. And that means I have the number 4 and I'm going to multiply it by itself 2 times. So I'm going to have 4 and I'm going to multiply it by itself, 4 by 4, 2 times. The 2 here tells me I multiply the number by itself 2 times. If there was a 3 here, I'd multiply 4 by itself 3 times. So I have 4 squared, or 4 to the power of 2, is 4 by 4, which is going to give me 16. Can I do the same thing with letters? I can. Usually we'll go in the other direction, but we could break this up into x multiplied by x for x squared, and that's multiplied by y cubed. So that means y multiplied by y multiplied by y. The 3 here tells me I multiply y by itself 3 times. So I have x multiplied by x multiplied by y multiplied by y multiplied by y. That's what this means. This is the expanded version of this. We'll often have to start from here and simplify to here, but we can go in the other direction as well. Now, let's put this into practice with some other examples. So I have 3x multiplied by 4xy. So I have 3 multiplied by 4 multiplied by x multiplied by x multiplied by y. So I'm effectively gathering the like terms in my head. So let's do the number parts first. So I have 3 multiplied by 4 is going to give me 12. X multiplied by x, there's only two x's multiplied together, so that means x by x would be x squared, and that's all multiplied by y. So that is my final answer there. So even though this looks quite complicated, it's made up of little bits that we can do very easily. So I know I have a 3 and a 4 multiplied together. I know how to do that. X multiplied by x just means x squared. All of that is multiplied by y. And I just have them all stringed together, and I have my final answer. And again, this looks quite complicated, but it's all made up of separate bits that we're able to do individually. So let's actually underline these as we go. I have the number part, and I have the A part, and I have the B part. You don't have to do this is similar to what we do if we were adding up like terms. But this is just to highlight that this bigger problem is made up of little bits that we can fairly straightforwardly do. So I have plus 2 multiplied by minus 5. So the number part that I always do first is going to multiply out to minus 10. And then I have a squared, so that means a multiplied by a. And I have another a multiplied there. So I have a multiplied by a multiplied by a. So how many a's do I have multiplied together in total? I have 3 of them. So that's a cubed. And now the b, I have 1b multiplied by b multiplied by b multiplied by b. So I have 4 b's multiplied together in total. So this is why it's useful to be able to expand out like this, because I can see that y cubed would be y by y by y. So b cubed is b by b by b. And then that's multiplied by another b. So I have 4 b's multiplied together in total. So let's use this in combination with what we know about multiplying our expressions. So we have 6x multiplied by 2x minus 5. So I know that the number outside the bracket gets multiplied by each thing inside the bracket. So that would be 6x multiplied by 2x plus 6x multiplied by minus 5. And now I'm back to the situation I had here. So I have 6 multiplied by 2 is going to give me 12. X multiplied by x is going to give me x squared. I have 2 x's multiplied together. And I have plus 6 multiplied by minus 5 is minus 30. And I have x multiplied by, well, there's no x here, so that just means the x is multiplied by my numbers. And that's as far as I can go because these aren't like terms. This is x squared and this is just x. So I cannot add these two or subtract these two from each other because this is a different type of term to this one. If we want to think about it, x could be a length, and that would mean that x squared would be an area, to give a physical example. Now, let's keep going. So I have 4m squared, and I'm going to multiply it by each thing inside the bracket. So I draw in my guidelines to get it stuck in my memory of what I need to multiply. So I have is equal to 4m squared multiplied by a plus 4m squared multiplied by m. So this one I can do very little with, but I can make it a little bit neater. I'll write it in alphabetical order. So I have 4 multiplied by a multiplied by m squared. 4 multiplied by a multiplied by m squared. So I've written it in alphabetical order. And I can see that the squared is only on the m. So if I want, just to be clear about it, this can look a little bit like 4am all squared, but the square is only on the m. So when we write it like this, it means that the m is the only thing that's squared. If we put brackets around all of this, it would mean that a and m were both squared. So we just need to be careful of that when we're writing our indices. The power is just on the letter that it's immediately to the right of. So continuing on, we have 4m squared multiplied by m. So now I have 4, I know there's a secret 1 in front of this, so I have 4 by 1 is 4, and then m squared is m multiplied by m, and this is multiplied by another m. So m by m by m is 3 m's multiplied together. And again, that's as far as I can go, because this is m squared and this is m cubed. So if this was an area, this would be a volume. So I can't add different types of things together. They have to be exactly the same type of term. So continuing, I have my letters here. This time I have two brackets I need to deal with. So I have k multiplied by each of these, and I have a minus multiplied by each of these. If it makes it easier for ourselves, we can imagine that there's a -1 hidden here, but you don't have to. So I have k multiplied by k plus k multiplied by 2. And then I have minus multiplied by 4k and minus multiplied by -3. I should have an equal sign there. So k multiplied by k is 2 k's multiplied together is k squared. And then I have k multiplied by 2. That means 2k. This means k multiplied by itself twice. This means 2k, so k plus k. So we need to be careful. These two are very different things. And then I have minus multiplied by 4k is minus 4k. So it's plus 4k multiplied by minus is minus 4k. Minus by minus is plus 3. And then I see I have some like terms. So k squared. I have 2k. I'm minus 4k. I'm left with minus 2k plus 3. And that's as far as I can go. Now here I have something a little bit more adventurous looking. I have y squared multiplied by 4x plus y. I multiply what's outside the bracket by each thing inside. And I have xy squared on 4x multiplied by 4x plus, there's no symbol here, so that means a plus x y squared on y. And now I just do each part individually. I know there's a hidden 1 in front of these, so I have 1 by 4 is 4. Should have my equal sign. 4 x multiplied by x is x squared multiplied by y squared. And then here I have secret 1's, so I don't need to write them down unless I want to. So 1 by 1 is just 1. If you wish to write 1, you can. X is just multiplied by the rest of it, so I just have x. Y squared is y by another y is 3 y's multiplied together. And that's as far as I can go here, because these aren't exactly the same kind of term. It's not x squared, y squared in both of them. Now another thing that can happen is we can be asked to do substitution that involves lots of powers. So let's practice that. We have a is equal to 3, b is equal to -2. So let's put in anywhere there's an a, I'm going to put the number 3. Anywhere there's a b, I'm going to put the number -2. So it's going to be 4 by minus 2 squared times, I know they're sitting next to each other, so that's times, I did that wrong, my apologies. A is 3 squared on minus 2 for B, I apologize, plus 5. I know 3 squared means 3 by 3, so 3 by 3 by minus 2 plus 5. So I have multiply here, I have 12 by 4 by 3 is 12 by 3 by minus 2 plus 5. 3 by 12 is 36 by minus 2 plus 5. 36 by minus 2, so plus by minus is going to be minus 72 plus 5, and then minus 72 plus 5 is going to be minus 67. And that's my final answer. And then using the same values for a and b, I have a squared minus 2ab minus b squared. So a squared is going to be 3 squared, a is 3, minus 2 by 3 for a, and b is minus 2, minus 2 squared. And now we're just doing BIMDIS as we have been here. So 3 squared is 3 by 3. And then I can do a little bit of this multiply, or I can keep everything for a moment. And minus 2 by minus 2. So 3 by 3 is just 9. And then I have minus 2 by plus 3 is going to give me minus 6. And that's still multiplied by my minus 2. And then I have minus 2 multiplied by minus 2 is going to be plus 4. And then I have 9 minus by minus is plus 12 minus 4 is equal to 9 plus 12 is going to be 21 minus 4. And 21 minus 4 is going to leave us with 17. So we can see we're just doing BIMDIS here once we've subbed in. So this is what we need for our indices and multiplying expressions.